Hi everyone, welcome back to my channel Vertex MrRoy. In the last video, I have already explained the sketch of the absolute value function, which is linear function. That's how we can use step number 1 and 2 to find the vertex by making modulus equal to 0, and we can find the domain when we required, and we can draw the function like the sketch. So today we are doing question number 3 of exercise 9.4. Let's see. In question number 3 of exercise 9.4, we have all equations are function, but one thing, we are doing only linear. This is linear, all are linear equations, so it's okay, we can do it. So step number 1, to draw the sketch of first part, f of x minus 3. The step number 1 is to find the vertex. Vertex means we have to make the modulus equals to 0. X minus 3 equal to 0. Only x minus 3, not the whole equation. So x is equals to 3. This 3 should be substituted here. 3 minus 3 is like 0. So it's coming. Vertex is coming 3, 0. Step number 2 is what we do, we find the domain. Like domain is given here, so we find the image of like f of 0. We need f of 0. So f of 0 is coming 0 minus 3 is coming minus 3, and minus 3 means it will become positive, so it's coming f of 0 is coming 3. So the next coordinate is 0 comma 3. Now we have vertex, we have like minimum value of y, which is like domain, and range. Now we substitute f of 3. When we substitute f of 3 is coming 3 minus 3 and it's coming 0. So it's coming once again 3 comma 0, which is same as the vertex. So altogether we have only two coordinates now, like 3 0, which is same here 3 0. So we have 3 0 and 0 3. When we draw the sketch of this part, it's very simple. We do not need the graph paper. For a sketch, we just need a small like size. There is no issue. The domain is 0 till 3 means we can have 1, 2, and this here is 3. And this is y-axis, this is x-axis. Now, what is the maximum value of y? 0 and 3. The maximum value of y is also 3. So what we do, it's very simple. Now put all the coordinates. The first coordinate is 3 0. Like 3 0 is here on x-axis, and 0 3 is here on y-axis. And when we join this, it's very simple. We cannot have like this because the domain is only 0 to 3. Now one thing I want to add here, yes, we have to also find the range of the function. Okay, the range means for the range we always take the value of y. So range, like what is the minimum value of y? Like we do like this one, I can use this one, and this one. The sketch is ending and starting here. So what is the minimum value of y? The minimum value of y is 0 and maximum 3. So we write the range is 0, and same we write here, only less than, and this is f of x, and this is like 3, and we have done it. The range is also coming 0 to 3. This was question number like 3 part A. Next part is B. In part B, what we do in B part, the function is like x plus 2. What we find first, we find vertex. Vertex means 2x plus 2, only the modulus should be 0 and x is equals to minus 2. The vertex is coming, the vertex, like we have v shape minus 2 comma 0, because minus 2 when you substitute here is coming 0, because nothing is outside. When we have something outside, the vertex like will not be here 0, it will be something else. Next step is we use domain minus 3. F of minus 3, when we substitute f of minus 3 is coming minus 3 and plus 2 is coming minus 1, and minus 1 in the modulus will become positive. So f of minus 3 is becoming what? 1. So the coordinate is -3, 1. Next step is to use the maximum domain, which is 3 here. F of 3 I will find. So this we write 3 plus 2 is coming 5, and 5 is already positive. So f of 3 is equals to 5, and the coordinates are 3, 5. Now we need to draw the sketch of this part. For a sketch, we do not require the graph paper, like only the sketch, and we can like complete this here. What is the minimum value of like domain is from domain of the B is -3 to, so this we can write here. We do not write everything, is -3 enough, and 3 is enough here. Okay, the domain is given. The range, the value of y is 0, 1 and 5. 0, 1 and 5 means the value of y is not negative. So we can write 1, 2, 3, 4 and the 5. So this is y and this is x. Now we have to put the coordinates now. -2, 0. -2, 0 is here. This is -2, 0. -3, 1 is coming here. And 3, 5 is coming here. So now very simple, we have to join this with here and we'll join with this V-shaped graph, and we have done it. Now if you want to find the range of this question, range means what is the minimum value here. I have to write here, it's not visible. What is the minimum value of this graph? The minimum value is here and the maximum value is here, because the graph is like vertical, you can see from like it's not going down. So the minimum value is 0 and this 5. So the range of this question will be from 0 to 5. Now problem is what sign we need. We use the same sign and we have done the range. So now next question is question number 3, part C. So question number 3, we have the equation f of x is equals to 2x minus 1, and nothing is here, and the domain is from -1 to 3. So very simple step. What we need the vertex first. The vertex means 2x minus 1 should be equal to 0, and x is coming like positive is 1 upon 2, and when we put 1 upon 2 here is already 0, so it's coming, the vertex is 1 upon 2, 0. Okay, the vertex is here. Now what we need the -1 to substitute the minimum domain. -1 is giving us 2 times -1 is coming 2 minus 2 minus 1 is -3, will become plus. So we write f of -1 is becoming plus. So the coordinates are -1 and 3. We got first coordinate, second coordinate. Now moving to the third coordinate by using the maximum domain. So the maximum domain is 3 now, and when we substitute 2 into 3 and -1, the result is coming 6 minus 1 is 5, and f of 3 when 5 is, so the coordinate is 3, 5. So we have 3 coordinates now, and what we have to do, we just need like axes, not the graph paper, and just very simple here. And what we need, like we have to label -1 to 3 means our like target domain is 1, 2 and till 3, and is enough. We do not need to make more. This is y. What is maximum y? Here is 0, here is 3, here is 5. The maximum y is 5. So I'm just making, and I'm not writing 1, 2, 3, 4. I'm just writing only 5 is enough, because we are drawing the sketch, not the graph. Okay, now what we have to do, just put the coordinate. The first coordinate of the vertex is half and 0. The half is here and 0 is here. So this is the first coordinate of the vertex V, where we have the V-shaped graph. -1, 3 is coming here, and 3, 5 is coming till here. So just very simple, we can join it, and this is, we do not need the y-axis to find. It's very simple, and you can do now. What we need, we have to find the range. Range means what is the maximum value of the graph here and here. This is the minimum and maximum value. You can see the value of y is 0 and the value of y is 5. So it means the range of this question is from 0 to 5. So now we need to write inequality here. This is only greater than and this is less than equals to. So we can check the answer if you wish. 0 to 5 is the answer. 0 to 5, we have done it. And one more thing here, this 0, like this 0 is coming here, so this is better to write here equal to, because when you observe this one, this 0, like on y-axis, this coordinate 0 is not on -1. If we have, like, suppose the domain is from this point to here, then this will be like only not equal to. So equal to is there because we are not at the end position. So now moving to part D. In D part, what we need? In D part, the question is f of x is equals to 3x minus 5, and there is nothing outside here. The domain is 0 to 3. So we need the vertex first. For vertex, what we need? We write this modulus equals to 0, and x is coming 5 upon 3 and 0. So the coordinates of the vertex are 5 upon 3 comma 0. So 5 upon 3 means this is 1 point. When you check, by like you can check, this is 1 times 3 is 2, decimal 0, so 3 times 6 is 18, so it's 1.6 something. So just remember is after 1.5. Second step is to use the domain to find the range. This range, remember, the range, like normally we do not write the range from the given answer, because this is no, the range is always from the graph, remember, not from the solution. Please do not find the range from the solution. Use the graph to find the range. It's very important. Now I will substitute f of 0 now. When we substitute 0 is coming 3 times 0 and minus 5 is coming only minus 5, and when the modulus is there, when we remove is coming 5. So the coordinates are 0 comma 5. The next step is to use f of 3. So 3 times 3 minus 5, and is coming 9 minus 5 in the modulus, and is coming 4, and it will remain 4 positive. So the coordinates are 3 comma 4. Please, sometimes the mistakes are possible because I do in like questions in hurry, so I'm sorry for that, but take only the positive things. Yeah, okay. Now what we have to do, we have to do the sketch. Sketch means the domain is 0 to 3, means we do not, like, here is enough, 0 till here. This is the graph till here, 0. This is y-axis, and maximum value of y is 0, 5 and 4. So the maximum value is this 5, and that's enough. Okay, this is y, this is x. Now we need the vertex. Where is the vertex? Vertex is 1.6 means 1.6 means here, and 0 is here, something here, and we have 0, 5 is here, 0, 5 is here, and 3, 4 is something about here, and is always symmetrical, and we have done it. And to find the range of the question, please do not trust here. This is, you will not get the answer of range from here. The range of, like this, when we have vertex or the turning point, the range is always taken from the graph. So what is the maximum and minimum value? The maximum is 5, the minimum is 0. You can check. This is 5 and this is 0. So range is from 0 to 5. And one thing, this when you have the, like, 5 is on 0, means this should be like here. You can check 5 and the maximum, okay, 0. So now 0 to 5 we can write 0 with 5 is only less than. Remember, because 0, like you can check 0 and 5. 0 and 5, the x0 is only less than, not equal to, so I will not write equal to here. And when you write here with this 5 and okay, we have done it. Now we write with 0. 0 is coming 1.6 and 1.6 is in between this domain. So this should be also equal to. And we can check the answer by using the answers. The question is, you can see 0 is equal to and 5 is not equal to. So this is very important. 0 is equal to and 5 is not equal to, because 5 is with this 0 and 0 is already, here you can see, with not equal to, only greater than. So we have done this question number C and D. So question number 3, part E, the f of x is x minus 1 plus 1. Now we have something outside the modulus sign and the domain. So we need to find vertex first. Vertex means only x minus 1 should be 0, not the whole equation. So x minus 1 equal to 0 and x is equals to 1. And when we substitute this value, 1 means when we substitute f of x, the whole value is 0, then we have 1 now. So it means now the vertex is different, like vertex is 1 comma 1. Like in part A till D, we have nothing outside the modulus sign, so now vertex is something different. Next step, to find the domain with f of minus 1 is coming minus 1 and plus 1. Minus 1 is minus 2 plus 1 is coming positive 2. 2 plus 1 is 3. So f of minus 1 is coming 3. So the coordinates are minus 1 and 3. Moving to next part to find like f of 3, the maximum domain using. So 3 minus 1 plus 1 outside is 2 plus 1 is 3 is coming 3. So the coordinates are 3 comma 3. Now let's moving to the sketch. The sketch, we just need like not the graph paper and need the axis. What the domain is from minus 1 to 3. So that's your like domain, and the range means 1, 3 and 3. So maximum we have till 3, so that's good. We write till 3. This is why. Now moving to the sketch, vertex is 1 1. Vertex is 1 1 here, and minus 1 3 is here, and 3 3 is here. So then when we join this, it's a sketch V shape. Now, how to find the range of this question? So range means what we need, we do not need these values. We have to write what is the maximum and minimum value in Y. So minimum is 1 and maximum is 3. So the range is from 1 till 3. Now 1 is like in middle the like domain, so it's greater than equals to, and 3 is like you can see 3 is here at the corner of this domain, so that is also equal to, that will be like this, and we have done it. Then part f is f of x is 2x minus 5. We have modulus outside, like one value outside, so the vertex is 2x minus 5 equal to 0. X is equals to 5 upon 2 means 2.5. And please, this is not 2.5 comma 0. We have to find, like here, the whole value is 0. So 0 minus 2 is minus 2. So the vertex is now 2.5 comma minus 2. This is very important. Moving to the domain, minus like 0 to, first 0, substitute 0 in the equation is coming. 2 times 0 minus 5 minus 2 is coming minus 5 in the modulus, then minus 2 is coming positive 5 because of modulus, and it's coming 3. So the coordinate is 0 comma 3. Next domain using 5 was the range is coming. 5 is 2 times 5 minus 5 and outside is minus 2. 10 minus 5 is 5, minus 2 is coming 3. So the coordinate is 5 comma 3. Now to move to the sketch, like what we need just the like axes and what's the domain of our question is 0 to 5, so we need something like this part is here is okay. So domain is, we can extend this line, we can extend because we need more on x-axis. So domain is from 0 to 5, 1 2 3 4 5, and y maximum is minus 2 and 3. Okay, this is 1 2 3, and this is minus 2 is y-axis. Now sketch, we need first of all the vertex is 2.5 minus 2. 2.5 minus 2 is something here, and 0 3 is here, and 5 3 is coming something here. When we join, this is the v-shaped graph, and we have done. And what's the range of this question now? For range, what we need? Range, we need the maximum value and the minimum value. Minimum value is minus 2, maximum is 3. So minus 2 is in between the domain, so that will be equals to also, and 3 is with this 5, so I think it's also equal to, and we have done the range. So by this way we have done this, how to sketch a modulus function with linear equations. Thank you so much for watching my video and have a nice day.